I want to work out the even problems for the quiz review for the molarity. I know that some of you are getting this pretty well, but I know there's still a few of you out there that still need a little more assistance. Please, while you're working these out, pause the video for a moment, try to work it out. It's okay, this is a learning process. Pause the video, try it. If you make a mistake, erase and make the correction. But please benefit from these videos by learning from them. Let's look at question number 2. The question asks, determine the empirical formula for a compound containing 36.5% sodium, 25.4% sulfur, and 38.1% oxygen. When writing the formula, write the symbols in the order given. So in other words, generally speaking, whenever I give any question, always write the elements in the order that they're given. I know I just put that last part on there to assist you on that. So again, there is no gram amount given here, so we strictly have just percentages. So let's use the percentages to help us find out what the empirical formula is. So we have 36.5% sodium, so we'll go 36.5 grams of sodium. And the molar mass for sodium is 22.99 grams, and that's on your periodic table. We'll find out how much that is in a moment. We also have 25.4% sulfur, so we'll make that grams of sulfur. And the molar mass for that is 32.06 grams, and we'll find out how many moles that is. And the last one is 38.1% oxygen, so we'll go out and change that into grams as well. So 38.1. And the molar mass for that is 16. So let's find out how many moles of each we have here. For the sodium, I have 1.58, and let's not round that too much, so we'll go 77 moles. For the sulfur, I have 0.79, we'll say 23 moles. And for the oxygen, we have 2.38. 2.38, we'll say 13 moles. All right, so you have your mole ratio. So again, anytime you're given a mass amount for the elements and you're asked to find the empirical formula and maybe later finding the molecular formula, we always want to take whatever gram amounts given to us or percentages are given to us, change those grams into moles. Because again, when looking at the periodic table, even though the periodic table has different masses, and some of these masses are quite large in differences, like we've got 127 over there, we've got aluminum with the 26.98. True, even though we don't have the same number of grams for each of these, 26.98 grams of aluminum represents the same number of particles as 127.60 grams of tellurium. So we want to make sure that we're actually changing the masses into moles, so it's something that we can work with that's equal to each other. All right, so once we have our number of moles, we want to find out which of these moles is the least amount, because we want to find out the smallest whole number ratio. So looking at these, I see that is my smallest number, so I will divide everybody by that amount. So that top value is 2.00394, so we'll say it's 2. The next value is 3.00563, so we'll say that's equal to 3. So once you have your mole ratios, it looks like we have 2 moles of sodium, 1 mole of sulfur, and 3 moles of oxygen. So what we want to do is, again, we want to write out our formula. Let's do it over here. So we have 2 sodiums, we have 1 sulfur, and 3 oxygen. Now, some of you may recognize this or remember this from first semester. If we look at cover up the sodium, we have kind of a, it's not a derivative, but it's actually something from sulfate. It's 1 less oxygen than the sulfate, and it's sulfite. this still has a -2 charge. The sodium has a +1 charge. That's why there's 2 of those. So if you remember some of the naming from the first semester, looking at the charges to check your charges when you have a metal with a non-metal, especially from a polyatomic that has either 1 oxygen removed or 1 oxygen added to it. So N2SO3 is the answer for this first problem here. Question number 4. Determine the formula for a hydrate that is 42.3 grams tin, 50.8 grams chlorine, and 32.2 grams of water. Now, in this problem, I actually did not give you the molecular formula for this tin chlorine compound. So we get to determine that. However, we already have the formula for the water, so don't mess with that. So let's go ahead and find out what each of these actually is. And there's a couple ways you can work this out. You can find out what the compound is first and then compare that to the water, or you can do it all at the same time. We're just looking for the number of total moles here. So let's actually do it in the most efficient way here. So let's go 42.3 grams of tin, and we'll find out how many moles of that. And tin has a molar mass of 118.71. So 1 mole of tin is 118.71, and we'll find out what that is. 50.8 grams of chlorine, and 1 mole of chlorine has a mass of 35.45 grams. Find how much that is. And we have 32.2 grams of water. So again, that's all, we're going to leave that compound together. We're not going to mess with that one. Since the question gave us that, let's roll with that. And so the molar mass for water, and again, if you work with this enough, you will memorize this value. And so the molar mass for water is 18.06. All right, so let's find out how many moles we have of each. That 3 moles of tin. I have 1.433 moles of my chlorine, and 7.873 moles. All right, so what we want to do is, again, we're trying to get a ratio, and what's neat about this ratio is this ratio will give us our formula for this tin chlorine compound. So we'll divide everybody by this number, which seems to be the smallest. That's a 1, 3, 5, 6, 3. That actually equals 4.021. So we'll say that's a 4. And we'll divide everybody by 3, 5, 6, 3. So 5.01. So I think that's pretty safe to say that's a 5. All right, so now how do we put this together? Well, keep in mind that this is our compound, okay? So this stays together, and remember, the formula for a hydrate, we're always gonna have one of whatever it is, this tin with chlorine compound, and then looks like we're gonna have a ratio of 5 there. So let me see if I can cheat here and say, okay. So my formula is gonna look like this. I'm gonna have 1 tin, because of a ratio of 1, chlorine, I'll actually have 4 of those, and then my waters, I have 5 of those. So that means I have 5 water molecules chemically attached to that. So the answer to this one is, actually this, let's check and see if that's a legal charge. Tin can either be a +4 or a +2 charge, and in this case, it would be a +4 charge, because we have 4 of those, therefore it's a +4. So this is a good legal molecular compound. All right, let's look at the next one here. Make sure I got enough room. Oh yeah. Here's some bonus footage. I have an odd question in here. Number 5 says a sample was analyzed that contained 20 grams of carbon, 3.33 grams of hydrogen, 26.7 grams of oxygen was identified. Determine the molecular formula if the molecular mass is 180 grams per mole. So what this question is not directly telling you, but you need to do it to find the molecular formula, is you need to find the empirical formula first. You're not going to be able to just look at this information and go, I got it. So find your empirical formula, then find your molecular formula. So same thing, keep the elements in the order that they're listed. So we have 20 grams of carbon. Now let's find out how many moles of that is. Okay. We also have 3.33 grams of hydrogen. We also have 26.7 grams of oxygen. And 1 mole of that is 16 grams. So let's find out how many moles of each of these we have. All right, so for my carbon, I have 1.66, we'll say 53. Now, I know what some of you are thinking. That's 1 2/3. No, that's a mole amount. So we're not going to fractions yet. We have to find the smallest number ratio before we can do anything. This is 3.30, say 36. And the last one is 1.66, and we'll say 88. Again, these are still moles, so you're not changing that to 1 2/3, you're not changing that to 1 2/3, you're not changing that to 3 1/3. We want to find out what is the smallest number ratio of moles before we do anything. So now we're going to divide them all by 1.6653. That equals 1. Find out what that is here in a second. This is like 1.01 something, so that's very close to 1. And I'm willing to bet that that's going to be a 2. Nope, it's 2. So 1.97. So we're going to say that's a 2. So here's our, actually let's write the empirical formula. So we have 1 carbon, we have 2 hydrogen, and we have 1 oxygen. So there's our empirical formula. We're going to find the molecular formula. So the molecular formula mass is 180 grams. So again, what we need to do is we need to find out what our N is equal to. So we know we have 180 given to us. Again, that's in the problem. The molecular mass is 180. We need to find out what the empirical formula mass is. So we need to find out, okay, well, how much is this? Well, I have 12.01 grams of carbon, 1.008 grams of times 2, plus I have 16 grams of the oxygen, equals 30, all this equals 30.026 grams. So what I want to do with that is I want to take that 30.26 grams, bring it over here. Okay, and then we're going to find out how many times that's divided. Now, 180 divided by 30, hopefully you're all going to say, oh yeah, it's a 6. And it's very, very close to 6. So now what we want to do is we want to take our empirical formula. Okay, let's drop it down here. Move it back over. So now we have our empirical formula here. So we're going to take that 6 and multiply it. So now my actual answer is C6H12O6. So the way that we would box that in, there's my empirical formula, smallest whole number ratio. That's the the molecular formula. It is what it is. And if you took the molar mass of that, you'd find out that, yes, that is 180 grams per mole. All right, number 6. A sample of naphthalene was analyzed and the empirical formula was found to be, how nice, I gave you the empirical formula. C5H4. Determine the molecular formula if the molecular mass is 128 grams. So in this scenario, you're actually given the empirical formula, so you don't have to calculate it. So all we have to do is calculate for this N. Okay? So what we need to do is calculate for N. So N, and the molecular formula mass is 128 grams. And we need to find out what the empirical formula mass is. So we'll do 5 times 12.01, plus we'll do 4 times 1.008. And find a number there. 64 point, we'll say 0.82. And I'd be willing to bet that when you take that and put it right under there, that these two, that equals a 2. So what I want to do is, let's get rid of you, move you out of the way, rid of that, since we know our value. So bring you down here. So we're going to put the 2 there, and this is going to equal C10H8. So the empirical formula is given to you. There's the molecular formula. Number 8. Question says a compound that contains only nitrogen and oxygen is 30.4% nitrogen by mass. The molar mass of the compound is 92 grams per mole. Determine the molecular formula for this compound. I love these questions. Gets you to think. Now, again, let's look at what's in this. We have a nitrogen and oxygen compound. So you have nitrogen and oxygen, and you're looking for these values here. I'm not going to always give you all the information, but you'll have enough information to be able to determine what the empirical formula is. So use the information that's given to you. If it's telling you it's 30.4% nitrogen by mass, what must the other thing be, or what is the other thing? And most of us will look at this and go, you only gave us one piece of information. Look at the question, think about what is given and what you're looking for. This isn't difficult. This is an easy problem-solving process. All right, so let's find out, first of all, how much oxygen we have, because we know we have 30.4%. So we have 30.4%, or 30.4 grams of nitrogen. So that's 14.01 grams. And then we'll take the difference between 100 and 30.4. So 100 minus 30, 69.6. So we have 69.6 grams of oxygen. So we'll figure that out. And that is 16 grams. So let's figure out how many. All right, so it looks like we have 2.16, we'll say 99 moles of that, and we have, oh shoot, I already did, 4.35 moles of our oxygen. So again, which one is smaller? Divided by the 2.1699. That's a 1. 2.1699. This one doesn't look like, that's 2. I can see that's a 2. Yep. So it's very close to 2. So we have, it's a NO compound. Oh, I'm sorry, NO2 is our empirical formula. So now what we want to do is we want to find out what the molecular formula is. So we need to find out what our N value is. So N, and the molecular formula for this compound was 92 grams, 0.01 grams, plus 2 times 16, 46.01 grams. Now obviously that is half of 92, so our value is 2 there. Take the away. That's a 2, which means that, actually let's move you out of the way, move you down. So it's N2O4. So our empirical formula is NO2, and then our molecular formula is N2O4. Okay. Hope this video was helpful. Again, good luck on the quiz. But again, go through the problems and try to work them out. I should have the odd answers posted online for you.